The 20th century was the century of chemistry. Through chemistry, we learned to feed humanity and develop new compounds that improved every aspect of human existence, from raincoats to smartphones. Technology has risen together with chemistry as we learn to purify and shape silicon and other elements to meet the needs of electronics. At the heart of many technologies are a range of materials that rely on specific metals for performance and miniaturization. Not just metals that we know from daily life, like aluminum, copper, and gold, but more exotic ones like cobalt, iridium, and dysprosium have become essential. Chemistry has always been about getting the right stuff and transforming it into something useful. But at what cost? You've probably heard how blood diamonds support conflicts, and perhaps you've chosen ethically sourced free trade coffee. But have you considered that the cobalt in your smartphone may have been sourced from child miners in Africa? Or that the lanthanum in your electric car created tons of radioactive acidic pollution? In my lab, my group and I are developing new chemistry to enable recycling of critical, precious, and irreplaceable metals. We are seeking sustainable and even ethical new sources for critical metals to establish circular economies through recycling. The 21st century will be the century of chemistry, with the development of sustainable processes that support humanity at a high standard of living with low environmental impact. In Penn Chemistry, the future looks bright.